Okay, next up is Professor George Kukla. If I may show a little bit of my personal bias, Professor Kukla is one of the really pioneer in terms of the study of how the changes in the Earth orbit affecting the, I guess, the coming and going of ice ages. So this shall be a very interesting subject for us to hear. So, Professor Kukla, please.
Thank you. I should mark shift. I want to change the slides. You don't.
I can change it.
Wait. Oh. Which here? Here, shift. Yeah.
Just the arrow.
Oh, this one. Oh, yeah. Because I don't have this kind of this one. All right. Yeah, misunderstood global warming. I have a really hard time at this conference, especially after the breakfast today, to actually justify that we do have global warming. The certain difference from these talks today is that the global warming started 10,000 years ago already and is continuously increasing the average global mean temperature. Now, that would be
Here.
which one?
It's this one right here.
Oh, this one, yeah.
Right.
Okay, so you probably would judge that the responsible agent are the cooking women, or perhaps even all of these agents, but maybe all of them a little bit. But as for the impact of man, of humankind, that at this point, I even believe that it's negligible, almost negligible. Now, then perhaps...
It's this one right here on the end.
Oh, this one. Right. So, on the other hand, Gore was the vice president of the United States, no? So how could Gore be wrong? No way. But if we do have the global warming, perhaps, and global warming actually was lowest, the global mean temperature was lowest when the climate globally averaged was actually most benign at 9,000 or 8,000 years ago, at the peak so-called hypsithermal. So I will try to show you some slides which will make you perhaps believe a little bit more what I am blubbering here about. So
You want the next one?
this
that's
one.
it.
Oh,
That's
sorry. Now, this is the summary of the information that we got on the climate of the last 400,000 or 500,000 years. And these red bars on the side, those are the dated, radiometrically dated terraces, sea level terraces, and the blue points are another very precisely dated points in the Devil's Hole in Nevada. And if we compare it, this radiometrically dated evidence of the past climates, which is completely unaffected by theories. So, and compare it with what Milankovic, we don't hear on this conference too much about Milankovic. Milankovic is a forgotten guy. No one wants to talk about him anymore. But that guy must have been right. And this is the curve of what's under Milankovic. This is the curve of the equivalent latitude of the insolation hitting, which would correspond to what we today are getting at 65 north latitude. So you see that, for example, at 230,000 years ago, or better stick to just the last 116,000 years ago, that the insolation was considerably in this high latitude, considerably lower than it is today. It was only in corresponding to what today is coming to 75 north. Now, those were the starts, those were the times. We now have the evidence so precisely dated that we know that 116,000 years ago was the start of the last glacial cycle, of the major glacial cycle. Now, how come when the temperature was actually so low at 75? Now, that's clear proof that the temperature in the high latitudes must have been low as well if the insolation was so low. However, you wouldn't believe me, that was the time when the globally averaged temperature was the highest. And was the highest because the sunshine was oriented to the tropics. This is a little bit difficult to understand. The time goes from the right end to the 120 is the 1,000 years ago. That's the start of the last glaciation, about 225 or 226. Now, these green points at the bottom of the 22.5 obliquity position are actually times when you get a speeded build-up of the ice, of the global ice. Whereas opposite situation with the relatively high obliquity is these blue points on the top, which are marking the start of the interglacial. So, as you see, the high obliquity, 24 degrees, is the time of the warm, of the beginning of the warm times, and the blue one with the low obliquity, on the other hand, are the build-ups of the ice. So, okay. The problem of the globe is that it's a ball, it's not a tube. Most of these figures, you would think that it's just, the tropics and the high latitudes are equally white, no? in these pictures. But it's not true. Actually, between 30 north and 30 south, there is half of the global area. And if that, and it's basically oceans, if that,
That's a corner right there.
if that part warms up, so and it warms up because there is only a limited amount of insolation. You can't change it too much, the total which is coming from the sun. So then you have to use the insolation which otherwise would come to the high latitudes, and the global mean temperature is going up. Oh, this here.
No, it's right on the end here.
All right. Oh, I did it, yes. Great. So if you want to increase the tropical insolation, so you have to use the one which otherwise would come to the high latitudes, and then the global mean temperature would go up, and the high latitudes will cool. The other way is the high obliquity. That's the situation which actually correlates with the start of the interglacials. And this is start of the glaciers. Now the difference in the incoming energy is in joules per square meter. So it's really large. The zero bottom line is what the Earth was getting at 120,000 years ago. The global income, energy income. And it was considerably higher at 111 or 115 and 122. 115 was the start of the last glacial, or glaciation. Okay, so remember, low obliquity, the lowest obliquity is what marks the start of the glacial, which results in subpolar cooling. And it's at the expense of the more insolation coming to the tropics, where the increase is enhanced by the warming of the global oceans. And as a result, the global mean temperature, surface temperature is going up. So we have a global warming, and the global warming is the time when the ice started growing fastest near the poles. So it's a kind of contradiction, but that's how it is. It's the inconvenient truth using the terminology of our Vice President Gore. So we have global cooling at the start of the interglacials and global warming, and we do have global warming now, so be careful. Starting to get cold, possibly. Now, there's a nice paper recently, relatively recently published, showing that the temperature response to solar heating through the Holocene really was more or less what I said. So that paper is published in Paleogeography or something like that. Paleoceanography. And it's showing here the temperature calculated by the same sophisticated, super sophisticated models using for prediction of what's going to happen soon. So, or what's explaining what's happening now. So, and this figure is shown in, irrespective of the shape of it should be compressed from the sides, because the equatorial belt between 30 south and 30 north is actually 50% of the area. So, you know, these peaks of relatively warmer temperature at here at the higher latitudes. So it would be squeezed much more if it were pointed with respect to the really affected area. From 45 north to 45 south, it was warmer, but it was considerably cooler over 65% of the globe between these latitudes and the equator. I have to end soon. Yes, I will. Now, this is today. Okay, let's then return to today. Today we have roughly in the last 50 years, between 1950 and 2001, I guess this figure constructs it, we have broken it in 3 parts. Red are the temperature, global temperature in January, February, March, averaged for roughly 1/3 of the time which were classified as El Niño. Blue is La Niña, so you think that the two are compensated more or less, one with another, and the zero line is the remaining 1/3 of the time, which is labeled as normal. Now, okay. Now this is very interesting figure. It goes till the end of August last year, not this year, last year. So, and it's covering the time from 1950 to 2009. So, global mean temperature increased between A and B by 9 degrees Celsius. However, the low latitudes, just between 23.5 to 23.5 south, increased much more, increased by 13.5 degrees, okay? And you see the points, the high points of the temperature, the average temperature, which, you know, these, which are invariably correlating with El Niño, whereas the low points are correlated with La Niña, and they obviously are affecting the whole globe. So it's El Niño which is running the whole show. And if we look at the information that we have from the start of the last glaciation, so the more frequent Las Niñas at the end of the last interglacial switched relatively rapidly to more frequent El Niños, and that means the warmer globe with starting building ice at about 115,000 years ago, okay? And that's not too much based in models. It's no models, it's the relatively good reconstruction of what really happened. And if I want to be really pessimistic. So then, there was no time to read it, but anyway. Oh, this is the way back. Okay. So that's what we should expect at the start of the glacial. Continued global warming, marked by increased warming of the tropics, but relative cooling, it may not be so strong in the higher latitudes, and increased build-up of the ice. So the ice on Greenland is probably starting on top, growing as well as in Antarctica. Antarctica is growing, and that's how the slow glacial should start. Yeah. On the other hand, it's run by Milankovitch cycles, and Milankovitch cycles are the weakest in the last 400,000 years. So don't worry, we are safe for another 30,000 years.
Thank you very much.